let's go a little bit detail into the Hadoop 1.0 architecture. Where I'll also talk about the challenges here and why Hadoop 2.0 came in. So as I just said, right, the HDFS, which is the Hadoop distributed file system, this is the cluster on which your data is stored. Now it has a master-slave kind of architecture where NameNode is the master, which manages all the data nodes, your actual data, your actual video data, streaming data, your images, your text, everything is stored on data nodes, which is, there is one name node in a cluster, and there can be thousands of data nodes in the cluster. Okay, this name node is a high availability machine, which means it has redundant power supply, it has high amount of memory there. Now, what the actual data is stored in data nodes in terms of blocks, these data blocks, and name node contains the metadata, which means that it contains the information about where the data is stored, where the data is replicated. So all that metadata is stored inside the name node, and this is stored in the RAM of this name node. Okay, then there's something called a secondary name node, which keeps on taking the backup of the name node just in case of failure. Okay, just to introduce the term that this is still not a failover mechanism. So if the name node fails, everything goes for a toss. Now coming to the programming model, the MapReduce thing which I talked about in my earlier file, you have a job tracker, which is the core service or the thread which is running all the time, which is used for scheduling the jobs on the data nodes, and as well as for monitoring these tasks. Okay, so whatever task you have, whatever job you want to run on your cluster, it is submitted to the job tracker. Job tracker has a queue which will keep on submitting these tasks, scheduling these tasks to the various data nodes through a task tracker. Okay, and also keep on monitoring the job. So whether the job has failed, then allocate it to a different job. All this is done through the job tracker. Okay, so this is and finally the MapReduce program or the programming model which I talked about is a run on these data nodes, and you get this data back from this data node based on the whatever algorithm you've written in the map and reduce program through the task tracker. So these components together, the job tracker and the task tracker, are responsible for running your jobs on the data nodes and doing and whatever data you get back from that, you can do analysis over that. And the beauty here is that you can run all this in parallel in thousands of machines. So you are not restricted by your resources. You can just distribute these jobs in parallel across multiple machines, and you can get and the job tracker takes care of monitoring, scheduling, resource allocation. Everything is done by the job tracker. Okay. Now moving on. Now if you want to know more about it, I'm not going into details of this. If you want to more about it, there is a blog which I just sent through the organizer. You can look at that. That's a good blog which gives you details about these. Okay. Next, now Hadoop was solving all these problems, right? Now what is the challenge with Hadoop? So there was a need for re-architecting the complete Hadoop architecture. The architecture which we just saw, where we had this Hadoop distributed file system, on top of it MapReduce sitting there, and other tools. There was a need for re-architecting that whole architecture. The need came from the fact that there is no horizontal scalability of the name node. I'll go into these details, and then I'll introduce Hadoop 2.0. There is just one name node in the complete Hadoop cluster. So if you have to go beyond, say, 4,000, 5,000 nodes, there is a challenge or a bottleneck which comes in. Another thing which I wanted to bring here is that the name node is a single point of failure. So for any reason, if the name node fails, okay, then your cluster goes down. Now that is something which can be catastrophic. But there is a secondary name node there, but it just keeps on taking the backup, but that doesn't come up as soon as the name node fails. Okay, so it's not a high availability system. Though the name node itself is a very, very high availability machine, so you don't have, this is a very, very rare occurrence, but then as we grow, as the importance of data comes in, as the volume of the data comes in, this also becomes a very important feature that you need to have a backup name node there, which is not the case in Hadoop 1.0. Then I just told you about the role of the job tracker. Job tracker schedules the jobs, it monitors the jobs, it looks at the failures. So as your processing becomes huge, the job tracker becomes overburdened. Okay, I'll talk about that as well. Another very, very important thing here is that in Hadoop, anything which you run is run through MapReduce paradigm, which is it can be run only as jobs in batch mode. So if you have to run any other application on your data in HDFS, that's not possible in Hadoop 1.0. Hadoop 2.0 gets you there as well. Another very important feature which is missing from Hadoop 1.0 is multi-tenancy. Multi-tenancy means that at a single point of time, you can run only one type of job. Say, for example, you had your data stored in a Hadoop cluster and you were running a MapReduce job. In the same time, you want to run another job on that system, that is not possible. So you can run only one type of job. We'll go into the details so you'll understand it better. For now, just understand horizontal scalability is a challenge with Hadoop 2.0 as you grow your cluster size. NameNode is a single point of failure. The job tracker becomes overburdened as we increase the overall size, number of processes which run. And it's only possible to run a single type of application, which is the MapReduce or the batch kind of processing which can be done in Hadoop 1.0. Okay, so let's look at these one by one in a little more detail. Now, what is the challenge with this horizontal scale which I just talked about? So here is one simplistic view of your cluster. You have a name node which has all the metadata stored in the RAM of the name node, okay, and it does all the block management, and these are the actual data nodes where the actual data is stored. So what happens is that this metadata is stored in the name node memory, which is the RAM. Now you can just take the RAM to a specific size. I mean, beyond that you cannot vertically scale the RAM. Okay, so this bottleneck, and if you cannot do that, the system becomes slow. And this typically situation happens at a size of say 4,000 odd nodes. Okay. Now, just to tell you, the fact is that most of your applications which you would be running can be easily managed in 20 to 100 nodes. Okay. You will rarely see more than 4,000 nodes, but then larger organizations, be it a Twitter or a Facebook or any other large organization, or Yahoo, for example, requires bigger clusters than that, and that's where the need for having some solution to this came in. Now, if your memory becomes congested, then you will start seeing failures on your data node. You'll fetch the data, it will not return back on time, and you'll start seeing failures here. Okay, so that's one challenge with the horizontal scale. Beyond 4,000 nodes, if you try to challenge it further, okay, beyond 4,000 node, if you try to challenge it, scale it further, there comes a bottleneck. We'll see as we go to Hadoop 2.0 how is this managed in Hadoop 2.0 architecture. Okay. Next is the name node. I talked about the single point of failure.